So, hello everyone. So I'm going to talk about an ongoing research, which try to compare different way of representing and constructing graph from mobility traces. This work started when working with the worldwide maritime trade data sets. This topic is interesting because we have really a huge amount of data on this topic, and more importantly, over a large period of time. For instance, the data that I use here is extracted from the Lloyd List Intelligence database, and this is a very old insurance company that kept track of vessel movement worldwide. And so the objective is to understand how the transportation, how the maritime transportation developed and where it is going. In a recent paper, Wang et al. Discussed this topic, and they found, when comparing different periods, that recently the maritime network became more vulnerable to attack or to radical change, like, for example, fire in a port or something like that. But one aspect that is interesting to me is the notion of the shipping network, because there is actually several ways to look at mobility traces and to represent them as a network. So we can ask ourselves, maybe those differences are important, and what choice do we make, and what is the impact of the choice. To go into more detail, this is an example of a ship, the Copper, and an extract of the places, that the ports that visited this ship. In the Lloyd database, we have the list of ports, but also the arrival and sailing dates. So by sorting them according to the arrival date, for example, we can infer the movement of the ship and construct a network that include only the direct connection between the ports. However, the movement on ship are not there and back, does not follow there and back pattern. They visit multiple places. So another possible way to represent this is to represent all the indirect connection, saying, well, this boat went to this port, even though it did not went there directly. However, a drawback with this is the fact that, as you can see there, for example, a ship actually follows some commercial routes, and it can be affected to different routes even during the same year. For example, this ship started by connecting some ports in the Black Sea, and then went in the Middle East to connect it to Italy, and then it went on a commercial route in the Adriatic Sea. And actually, some researchers use directly the commercial route provided by the shipping company, but it's not our case here, since we use the actual places visited by the ships. But there is a simple way we can use to recover this commercial route, and this is procedure that I use. It's very simple and it's maybe not unique. It's based on the simple idea that the ship movements are optimized to spend less money, and ships most of the time follow a circle pattern where they do not visit a port more than 2 times. So we can cut recursively the sequence of ports visited in order to extract different routes. Notice that similar issues arise if we look at data coming from a satellite tracking system. That since you can go online on this website and follow the movement of every ship in real time, that possess an AES tracking system. So there is different dimension that we can use to construct the network, but actually those dimensions correspond to different measurements of the network. So if we take, for example, the degree, the space L corresponds only to looking at direct connection, and space P in space P, the degree corresponds to the reachable ports without changing route. And I forgot to say that space L and space P are the term used by a geographer working on this topic. So the same difference of interpretation can be made when looking at accessibility, for example, using shortest path distance. For example, in space L, the shortest path distance corresponds to the minimum number of visited ports in order to go from A to B. But with accessibility, there is also different dimension that we can incorporate in particular, and one of which is the temporal dimension, which is simply the time we need to go from one place to another. And most of the time, it is we defined it as a weight on the edge, and we calculate the shortest path using the edge. So in this case, the accessibility of a port will be the mean time it takes to go from this port to any other port in the network. But it still discards some relevant information, like the frequency of a link being taken, because the usage of ports in the world is far from being uniform. So one can take this information into account by, instead of looking at simple shortest path, looking at the length of the fastest journey that starts at a given time t. It is similar to when we plan a travel on a flight or train reservation website. So it will take into account the departure time of the ships, and the sailing time, I should say, and their arrival time. This can be done very easily by using a variation of the digital algorithm. But there is still another dimension that is not taken into account, is the sequential aspect of the data, because this is actually several ships that visit different ports, and a transfer of goods between ships is not free. You need to discharge the ship and then put the goods on another ship. So we could actually represent the network as a multi-layer network, where each ship movement represents a layer, and at a cost to the change of layer. But this can be done, we can show that it can be done in a more easier way by simply adding a cost to every internal node in a path. when working in space A or P. So here's some distribution on the different with the different representation built. So obviously we can see that space L, which is only direct connection, is far more sparse than the other. And using a procedure for detecting pathway, we significantly reduce the number of edges in the graph. And when comparing the sequential distance, which is the travel time, the average travel time all over the year 2009, you can see that there is really not much difference between the space P and space A, which is either using only pathway or only or taking every indirect connection, which is not really surprising. But I want to just point out the fact that it's risky to compare those dynamic shortest path distance, because the notion of connectivity is not the same in a static graph or in a dynamic graph. Therefore, each port has not the same amount of reachable ports depending on the period. So I also compare the average distance of ports against the sequential distance. The sequential distance here are at the x-axis, and we can see that with a cost of 0 for the stopover, the temporal distance are the best approximation for the sequential distance. But with the static graph, it's actually the number of stopover that is the best approximation of the sequential distance. This is even more true when looking at the sequential distance with a 2-day cost of stopover. In this case, the number of stopover, which is in space L, is the best approximation, even better than the temporal distances. So, to conclude, we can say that maybe the fact that the direct connection space L is a better approximation is not that surprising, because the idea between space P and space A is to say that we don't really care the number of steps it takes or the time it takes to go somewhere. We just want to know that we can reach this place from another place. And so for maritime data, if we do not have temporal information, maybe the sample number of stopover is a good approximation for temporal distances. And so maybe we need to, it is for the expert to decide whether or not he wants to include this temporal dimension in his work. And to conclude the ongoing research I'm currently working on, I want to investigate the implication of this for the design of higher order network model. To be simple, if static graphs are a representation of order 1 Markov chain, higher order network models actually models Markov chain of order higher than 2, and they can be used to better to predict the path taken by the ships. But in the previous literature, those models were used to predict the next port visited by a ship. But maybe we need to actually predict the route that is taken by a ship if you visit any given port. So that's it for my presentation. Thank you all for your attention.
Thank you. Any question?
So, there have been many works on airline.
Yeah.
So have you looked at trying to do your metrics on the airline network since it's a lot better known what basically the structure is?
Actually, no, I didn't. That's something I have to do. This is use different kind of transportation network. But actually, what was appealing, what was interesting with ship movement is that they will do multiple stopover, and which is kind of different from plane. If they stops, it's only for passenger to disembark or to recharge fuel. So I won't say it's less complex, but I mean it's different. But it's something I need to investigate further. Indeed.
So, I have a few questions. First, where do you find your data?
Well, actually, a colleague give it to me, but it is available.
Public or can we
No, it's not actually.
No, it's not.
No. Well, I made it public. The one I use, but actually, the Lloyd's company is a bit hard with giving data away. So
Ducruer is the guy who has been working on that for a long time.
yes, yes,
And he's still working on that? Or?
I think so. Yeah.
Okay, and you get the data from him?
Yes.
Okay. And he has the data for years or
Yes.
it started, I don't know, so...
Yes, but there are still, if I remember correctly, there are still issues with because most of the data is on paper actually, so very old registry. So there are and there are issue with numerizing everything.
Okay.
So, but yes, is the one you need to contact to have everything. But the data used for 2009 can be found on GitHub. Yeah.
The size of your data for 2009? What is how many nodes and
Well, with my transformation and a bit of filtering for very not ports that are not used at all, there is like 500 ports. Yeah, something. Yes.
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 Okay. I have another question. Are your networks directed or not?
Yes, they are.
They are directed.
Yes.
Because it doesn't look so.
No.
They are directed.
Yes.
Okay. And is there a finite number of routes, or can we create a new route? I don't know if you understand me. Because
No.
I think that routes for ships, you know, they have been for centuries like that.
Mm.
So can we think that in 2020 there will be a new route, someone will create a new route?
Oh yes,
Can I have the...
Yes, that's actually one of the challenge with this data is to try and see what the impact of a new route are going to be. For example, there is a canal that is built in Nicaragua by the Chinese to replace, I guess, the Panama Canal. And it's important to look at the history to try to understand what impact this is going to have on traffic. But you're talking more about simulation of such.
Is the dynamic, I would say, talking about the dynamic of the routes. is there a new route every year, or is
Oh,
there a new
okay.
route every century or something like that?
I really don't know. I didn't work yet on the dynamic of the thing, but well, I think there is still some the port that are that were important are still important. So Rotterdam, for example, is still important.
So my last question, so in your data, how many routes you can identify?
I don't remember actually.
But a lot? Is there
Oh,
10% of
well,
the ports or?
well, actually, during a year, the ships do not change route of route that much. I mean, the example I've taken, there is 3 change, but it's relatively small ships. Big ships, big transportment ship do not change route of route that often. So there is a lot of repetition actually.